In this session, let's discuss representation of sets from the chapter Sets. In the previous session, we have seen what are sets. Let us now see how do we represent a set. In general, we represent a set in two different ways. One way is called as the roster form or tabular form, and the other way is called as the set builder form or rule method. Let us now look at the roster form or tabular form of representation. In roster form of representation of a set, the elements are listed. The elements are enclosed within the curly braces and are separated by commas. Look at this example. I have a set A enclosed within the curly braces. We have the elements 3, 6, 9, 12, 15, 18, 21 and 24. Each of these elements is separated by a comma. Now if you observe, we are not given any condition here. Only the elements are directly listed down to us. Look at this example. 1, 3, 5, 7, 9, 11, 13, 15, 17, comma, I have a 3 dots here. The 3 dots here represent that the pattern of the numbers that we have here will continue. Now this is a set containing odd numbers. So I have 1, 3, 5, 7. So these are all odd numbers, odd natural numbers. Now after 17, this process continues. That is, we're going to include more and more odd numbers in the set. Look at this example. I have a set X as A, E, I, O, U. Now this is a set of vowels of English alphabets. Now all these elements of the sets are enclosed within the curly braces, separated by commas, and we have list of all these elements. That is, we are not trying to find out what the elements are. We are already given what elements of the set are. Let us now look at some interesting facts related to roster form. Now the order in which the elements are listed is immaterial. Look at this example. If I have to write a set of all whole numbers less than 6, what are whole numbers? Numbers starting from 0. So you have 0, 1, 2, 3, 4, so on. These are called whole numbers. Now all whole numbers less than 6 can be written as 0, 1, 2, 3, 4, 5. This is a set enclosed within curly braces and separated by commas. Now this need not be written in this particular order. You can also write it as 0, 2, 3, 1, 5, 4 or 1, 3, 0, 2, 5, 4 or in any other order of your choice. What is important is what elements you are listing down. What is not important is the order in which you write. Another interesting fact is that elements in the set are not repeated. That means to say all the elements of the set must be distinct. For example, if I have to write a set of letters forming the word Missouri, then it must be M-I-S-O-U-R but not M-I-S-S-O-U-R-I. Here, if you observe, the letter S is repeated twice. The letter I is repeated twice. So when we are listing them down, that is when we want to write the list of all the letters that is forming this word, we are going to look out only for the distinct letters and not the repeated letters. However, if you get to see this kind of sets which have repeated letters, it is always equal to the set of distinct letters that you must have in the set. Let us now look at set builder form or rule method of representing a set. All the elements of the set possesses a single common property f of x, which is not possessed by any other element outside the set. That set is described as x such that f of x holds good, and this kind of notation that you see here is called as set builder notation. What do we mean by this? F of x holds. F of x here we are talking about a common property which is possessed by all the elements of the set. So that property you can represent either mathematically if possible in the form of an equation or an inequality or in the form of a statement satisfying that condition. So if we are able to express this f of x as an equation or an inequality or a statement satisfying some particular condition, all the values which satisfy this f of x will be part of this set. This kind of representation of set is called as set builder form or rule method. Before we look at examples, let us see the working rule to write in set builder form. First, we start with a lowercase letter like x, y or z, etc. So we start with a small letter, let me say x. Then we write the symbol colon, and then this is followed by the specific property which is possessed by the elements of the set. Whatever is the property, we're going to write it here and enclose all these descriptions within the curly brackets. Now sometimes you also get to see that this colon, which is used to separate this variable and the condition, this colon, instead of colon, we also get to see a slash, or you also get to see a straight line, or you also get to see this symbol which means such that. Okay, so we read it as x such that this x satisfies so and so condition. Let us look at an example to understand this. Suppose I want to write a set A where A is a set of all natural numbers less than 10. So I start with a lowercase letter, let me say x. I put a colon and then I write the condition. What is the condition? This x must be less than 10 and this x must be natural number, the set of all natural numbers less than 10, and enclose them within the curly brackets. That means to say the set A is x such that x belongs to n and x is less than 10. Let's look at another example. I have a set B which is a set of all integers between -3 and 5. So if I assume this is a number line, this is -3 and say this is +5. All the elements between -3 and 5 must be the elements of my set. How can I write this in the form of set builder notation? Let me start with a lowercase letter, say x such that, what is the condition? This x must be greater than -3 and x must be less than 5 and this x must be integers, that is it must belong to set of all integers. You can also write the statement as x such that x belongs to z, that is set of all integers, and x lies between -3 and +5. Let's now have a very quick look to understand the difference between roster form and set builder form with the help of an example. Suppose I have a statement which says the set of all prime numbers less than 10. Now if I have to write this in roster form, I will list down the elements, that is what are all the prime numbers less than 10, 2, 3, 5 and 7. So that is given to us in the form of a list. The same thing if it has to be written in set builder form, we write it as x such that x is a prime number and x is less than 10. Suppose I give you another example like the set of all distinct letters of the word cricket. Now if you see C is repeated twice. If I have to represent the elements in the form of a roster form or in tabular form, we will not repeat the letters here. Okay, so we will write only the distinct letters. So that will give you CRIKET. The same thing can be written in set builder form as x such that x is a letter used in the word cricket. So what have we learned so far? We have learned how to represent a set in set builder form and in roster form. We have seen some interesting facts on roster form. We have seen the working rule of writing in set builder form.